we are discussing distance formula and midpoint of a line segment. So I will give you some more examples while solving these questions to apply this coordinate distance formula. There is a question in the exercise: show that the points A34 B 31 and C84 31 and C point is 84 are the vertices of a right angled triangle. So first of all, we have to prove that these three vertices, when we join these vertices, they will make a right angle triangle. And then afterward, we have to find the length of perpendicular from A to BC. Find also the length of perpendicular from A to BC. So definitely for the solution, we will first find all the three lengths of the triangle. So length AB will be calculated by distance formula: 3 minus 3 whole square plus 1 minus 4 whole square whole under root, because it is x2 minus x1 whole square, y2 minus y1 whole square. So it is 0 plus 9 square root of which is equals to 3. Then we find the distance of BC. So BC distance will be 8 minus 3 whole square plus 4 minus 1 whole square whole under root. Again this is 5 whole square, which is 25, plus 9 under root, so this is 34 under root. And third distance AC, 8 minus 3 whole square plus 4 minus 4 whole square whole under root. Again this is 25 plus 0, so it is 5. Now if we carefully notice that this is basically square root of 9 if you leave it in square root sign, and this answer can also be 25 square root or 5. Anyhow, we can clearly notice that square of BC is equal to square of AB plus square of AC. So what we do actually, which length is the largest length? Which one is the largest? 34 under root of 34 is the largest of these two lengths. So in a right angle triangle, we know that the largest side will be taken as the hypotenuse. So therefore, in this triangle, if I take BC as the hypotenuse, then BC square should be equals to AB square plus AC square. So if we put the values here, 34 under root whole square is equals to 3 square plus 5 square. So therefore 34 is equals to 9 plus 25, and this is also 34. So it verifies that these three lengths are basically the lengths of a right angle and triangle, and in this right angle triangle BC is the longest side, and this BC will be considered as hypotenuse. If we make a sketch of this triangle, then we can assume that this is AB, ABC is the triangle, and A is basically the right angle of this triangle. So now we have calculated AC as 5 and AB as 3, and this length as square root of 34. Now it says find also the length of perpendicular from A to BC. So if I make a line segment perpendicular to BC from A, then we have to find the length of this side. Let me suppose it as H. To find the length from A to BC, perpendicular length, we use the area of triangle formula. Area of triangle ABC is very easy now. It is 1 by 2 base into height. You have learned this formula in your previous classes. The area of a triangle is always half time the length of base and height. Now if I consider the area of triangle and the base and height are 3 and 5, then area will be 1 by 2 5 into 3, which is 15 over 2. So this will be the area of triangle ABC. But now if we want to find the length of altitude from A to BC, then area of triangle ABC can also be written as 1 by 2 times BC into this height. Let me suppose this point as D. So we can say that the area of triangle can also be written as 1 by 2 BC. BC will be taken as base, and this AD becomes the altitude. For example, if the triangle is drawn in this way, then A, B and C, this angle is right angle. So you have to find now the height of triangle from A to BC. This height we have to find, okay? And if this point is D, so definitely we can find this height with the help of same area of triangle formula. So now as we have calculated area of triangle ABC as 15 over 2, so we put this here. 15 over 2 will be equals to 1 by 2 times BC. The length of BC is 34 under root into the length of AD. We have to find this length. So if we shift these terms here, so AD will be equals to 15 over 2 times 2 over 34 under root. 2 and 2 they cancel each other. So AD will be equals to 15 over 34 under root. 5.83 is the value of, so 15 over 5.83, and if we divide 15 divided by, so 2.57 units is the height from A to B, C. So in this way it's a different problem, but here we are using the area of triangle formula, and then with the help of area you can find any altitude if all the sides of the triangle are given. If all sides are given, then you can find the altitude with the help of this form. Similarly, yesterday I have explained you before if you are given, question is that A is minus 3,4, B is 5,4, C is a 0.5 and 8, and in the question it says find D such that A, B, C, D becomes a rectangle. If A, B, C, D is a rectangle, then we have to find the value of D. Again, we suppose that let D be A and B. So definitely, if it is a rectangle, ABCD. If it is a rectangle, then one property we have learned that the midpoints of the diagonals are exactly the same in a rectangle as well as in a parallelogram. So we use the same technique. First of all, we find midpoint of AC. So AC midpoint is minus 3 plus 5 over 2, 4 plus 8 over 2. So it is 1 and 6. Then midpoint of BD. Midpoint of BD will be A plus 5 over 2, B plus 4 over 2. As midpoint of AC and BD are equal, so by equating A plus 5 over 2, B plus 4 over 2 with 1 and 6, we can get the value of A from here. A plus 5 over 2 is 1 and B plus 4 over 2 is 6. So A plus 5 is 2 and A will be equals to minus 3, and B plus 4 is equals to 12 and B will be equals to 8. So therefore we get the coordinates of D as minus 3 and 8. But again there is a confusion in this question. Before this problem I have solved another problem in which you have to find the value of fourth vertex such that ABCD is a parallelogram. So how can we differentiate whether it is only a parallelogram or this is also a special type of quadrilateral which is also called rectangle? So how can we verify it is also a rectangle? So it is very simple. When this quadrilateral is a rectangle, then it means these angles, they are all 90 degrees angle. So it means if so, then triangle ABC will be a right angle triangle. So as we have done before, if this is a right angle triangle, we can verify it with the help of Pythagoras theorem. So we do the same steps to verify whether it is a simply parallelogram or it is a rectangle as well. So what we do with the help of this fourth vertex minus 3, 8. So now D is minus 3 and 8. Now we find the distance AB. AB distance is 5 plus 3 whole square, 4 minus 4 whole square under root, which is 64 under root is 8. Then distance of BC. BC will be 5 minus 5 square plus 8 minus 4 square under root, so it is 0 plus 16 under root, which is 4. And then if I find AC distance, so it is 5 plus 3 whole square, 8 minus 4 whole square whole under root, which is 64 plus 16 under root, so it is 80 under root. So now it is very clear AC square is equals to AB square plus BC square, that is under root 80 square is equal to 8 square plus 4 square. So 80 is equals to 64 plus 16, so 80 is equals to 80. So it means we have proved that this triangle ABC is a right angle triangle. It means this angle is 90 degrees, and hence we can conclude that this this is a part of rectangle, and therefore this quadrilateral ABCD is a not only parallelogram but it is a rectangle as well, because every rectangle is a parallelogram, but every parallelogram cannot be a rectangle. So therefore ABCD is a rectangle. We have proved this. Similarly, in the exercise another important question is given here. You have to find the coordinates of a point. A is a point -2, 6 and B is a point 9, 3. It says find a point C on x-axis such that AC is equal to BC. First of all, here it is very clear that we have to find a point C which is lying on a particular axis, and here the axis is written x-axis. It means if I suppose, let C be a point whose coordinates will be A and 0, because on x-axis, when we take a point on x-axis, so every point on x-axis has y coordinate 0. If this point is 2, so we write 2, 0. If this is 4, we write 4, 0. And for this point we write 3, 0. So therefore on x-axis y coordinate is 0. Similarly, if the point is given on y-axis, this is our y-axis line. So on y-axis every coordinate of x is 0. So this point will be considered as 0, 1. This point will be considered as 0, 8, for example. And if this is here, if there is a point in the negative side, we write it as 0, -6. So therefore on y-axis x coordinate is taken as 0, on x-axis y coordinate is taken as. So I have supposed that let C be a point which is A0. Now as it is given AC is equal to BC, so we get an equation from the distance formula. AC distance, how will find AC? A minus -2 whole square plus 0 minus 6 whole square whole under root. This is equal to BC. It is A minus 9 whole square plus 0 minus 3 whole square whole under root. So this is basically minus into minus, it becomes plus. So we can expand this square. A square plus 4A plus 4 plus 36 under root is equal to A square minus 18A plus 81 plus 9 whole under root. Now we can cancel both square root sign from both sides by taking square on both sides. So if I take square on both sides, so definitely this square root is cancelling with this square. So we have left with only A square plus 4A plus 40 is equal to A square minus 18A plus 90. Now if we bring these terms here, A square plus 4A plus 18A minus A square is equal to 90 minus 40. So from this equation we get A square is cancelling with A square, 4A and this 22A is equal to 50. So A will be equals to 50 over 22, which can be written as 25 over 11. And so the point C is 25 over 11 and 0. This is actually the point such that this point is equidistant from A and from B. So therefore if you can make a sketch of on x-axis and y-axis, so you can find -2 and 6 is this point, this is A, 9 and 3 is this point, this is B. So therefore C is 25 over 2. It is approximately 2 point something, so it is here. So this point is C, such that it is on x-axis, such that the distance between BC and AC is same. This distance is same. It means there is another thing from here we conclude, okay, then this ABC triangle is also considered as an isosceles triangle. If I join A to C, then we can conclude that triangle ABC is an isosceles triangle because two sides are equal in it. Now we are going to discuss about the gradient of a line, distance formula, and midpoint. You have learned these concepts. Today we